Here are the last 4 questions from the challenge with the SOHCAHTOA that I sent you last week. Okay, so this time we have a triangle ABC and BD is perpendicular, so right angles to AC, as we can see, and we've got the various measurements. We've got to find this angle X. Now, to find an angle in a right angle triangle, we need to know 2 side lengths, but here we only know one of them. We haven't got a way of finding out AB, but BD is also part of the triangle BCD. So we can use our right angle triangle BCD, find out BD, and then pop it into the triangle ABD. So it's a 2-step process. Okay, so let's just focus on BDC at the minute. So that's my slightly wobbly version of BCD. There's 47 degrees. Okay, and we have a nice right angle. And we know that this length is 5.2, and we want to know this height here. Okay, so let's start labeling. Let's label our triangle with opposite, adjacent, hypotenuse. Hypotenuse is the longest side, opposite is going to be where H is, and next to the adjacent is next to 47. So we have information on the opposite side and on the adjacent side. Let's just remember SOHCAHTOA. So we've got O and A, so we're going to be using tan. So we write our equation for tan. So tan of the angle is equal to the opposite side over the adjacent side. And then we solve that equation. So to get H on its own, we multiply through by 5.2. Okay, and then we use the calculator. Right, that gives 5.58. So I'm going to keep the number on my calculator. I'm not deleting it, so I can use the answer button to be as accurate as possible when I use it again. Right, so now we're in a position to be able to sketch the other triangles. So A, B, D. Ooh, got a bit mad there, but never mind. And we want to find angle X. We know now that this height is 5.58 and we've got 2.4 along the bottom. So again, we're going to label with the opposite, adjacent, and hypotenuse. Okay, so hypotenuse is the longest side, 5.58 is on the opposite, we've got the adjacent next to X. We have information on the opposite side and on the adjacent side, so using SOHCAHTOA, O and A, we're going to indeed be using tan again. Okay, so we'll write down the equation. So tan of our angle is equal to the opposite, which is 5.58, over the adjacent. Okay, so to get X on its own, we need to inverse tan. So undoing the tan. Okay, and we just type that on the calculator. Now I've kept my answer from before, so I can do inverse tan of, and then we do my fraction. I'm going to use the answer as my numerator and 2.4 as my denominator. I get 66.7 degrees. Okay, well, let's try the next question. Right, no pictures here, so I'm going to draw some pictures. A ship sails 5 kilometers at a bearing of 160. Okay, bearings, we need some north lines. Mine might be a little bit wonky. So measuring clockwise from north, 160 is somewhere like this. Let's put our, our 5 kilometers. Okay. And that is 160 degrees. Marvellous. Right, followed by 7 kilometers on a bearing of 30. Okay, so let's do another north line. Okay, and now we're going 30, a bit further. Okay, and we're marking our 30 degrees and 7 kilometers. Ooh, they're a bit naughty in the question. They should have a 0, 30. Right, what's the question? What distance due east is the ship relative to its original location? Okay, let's just kind of sketch out what's going on there. So how far due east? So the first part of the journey, we've got that far due east. And for the second part of the journey, we've gone that far due east. So what we can do is we can kind of split into some nice right-angled triangles. So the first part of the journey, we've got this triangle here, and the angle in there, remember we've got 90 degrees, the total's 160, so that's going to be 70 degrees, isn't it? Okay, and then for the next part of the journey, I'm going to just move that line. Oh, I'm going to try and move that line. Okay, so I'm going to move this line to make a nice right-angled triangle to make this a little bit easier. Let me just try and get the 7 kilometers rewritten on there so that it's less confusing. Okay, so let's just look at this right-angled triangle for our second bit of journey. Okay, so the total distance east is going to be this blue bit along the top plus this green bit on the bottom. So I'm going to call this part X and this part Y. Okay, let's just focus on that first right-angled triangle. So I'm going to draw it out separately so it's a little bit less confusing to look at. We worked out this angle is 70 degrees, doesn't look it, but it is. And we want to know that distance to the east. So let's go about labeling opposite adjacent hypotenuse. So we've got hypotenuse, we've got adjacent, and we've got opposite side. We've got something on the adjacent side next to the 70. And something on the hypotenuse opposite the 90. Okay, so if we remember SOHCAHTOA, and we've got adjacent hypotenuse, we're going to be using cosine. So we write the equation, so cosine of the angle is equal to the adjacent side over the hypotenuse. To solve it for that eastern distance x, we're going to multiply both sides by 5. Okay, so far, if I do that on the calculator, that gives us a distance of 1.71, and I think that'll be kilometers. Okay, right, let's have a little look at the second section of journey. So we'll draw ourselves a nice right-angled triangle to represent that. Okay, now we've got 7 kilometers. We need to know an angle inside the triangle. Now if you look, we've got some nice Z angles there, you see, which is alternate angles. So that means I know that the angle at the top of the triangle is 30 degrees. Or you could have used 90 degrees, take away 30, gives you 60 at the bottom. It's your choice. Okay, I'm going to label that with opposite adjacent hypotenuse. Hypotenuse is the longest side opposite the 90 degrees. Next, and then the adjacent side is next to the 30 degrees and also the 90, and the opposite is opposite the 30 degrees. We have information on the hypotenuse and on the opposite side, so then we're going to be using sine. So we write down sine of our angle is equal to the opposite over the hypotenuse. And to solve that, we just need to multiply through by 7. Okay, and then if you do it on your calculator, you get 3.5 kilometers. So the distance east is going to be 1.71 plus 3.5, so that's going to be 5.21 kilometers. Okay, now because I had given this answer to 3 significant figures and 3.5 is exact, okay, then that's going to be correct to 3 sig figs.